Welcome to Red Dragon Mission Training. Training number 5, Momentum. This video tutorial will cover the following learning targets. Follow along, answer the questions, and master these skills. Momentum is the product of an object's mass and velocity. It was discovered by Sir Isaac Newton even before his 3 laws of motion. It led to the law of inertia. Specifically, an object at rest stays at rest, or an object in motion stays in motion. Momentum is just moving inertia. The more mass an object has, the more inertia it has, so the more momentum. The faster an object moves, the more momentum it has. Here's our formula. P equals m times v, or rho equals mass times velocity. The P, or rho, represents momentum. The unit for momentum is kilograms meters per second. M in our formula represents mass in kilograms, and V in our formula represents velocity in meters per second. Momentum can either be positive or negative depending on the direction. If I'm moving forward, I have positive momentum. If I'm moving backwards, I have negative momentum. The impulse is the change in momentum. To find it, we subtract the momentum before and the momentum after the change in momentum. This involves either changing the mass or the velocity. In most cases, you will see the velocity change. The mass does change from time to time. To do this, we need to look at Newton's second law. F equals ma. If you want to change an object's momentum or velocity, you need to apply an outside unbalanced force. Impulse is when you jump and land. You bend your knees. You're manipulating or lengthening out that force. Your impulse is the same, but by increasing the time, you decrease the force. This is also why you follow through when hitting a ball or kicking a soccer ball. Your force is the same, but by increasing the time, by following through, you increase the impulse, which changes the velocity since the mass remains the same. If the momentum increases and mass stays the same, velocity is the only thing that logically could increase. To calculate the impulse, we have a few formulas. The impulse can be the force times the amount of time the force was applied, or we can look at it as mass times the change in velocity. So impulse equals mass times final velocity minus initial velocity. You can also just simply look at it as the change in momentum. If you know the final momentum and the initial momentum, subtract them. Let's try an example problem. A tennis player returns a 30 meters per second serve straight back at 25 meters per second after making contact with the ball for 0.5 seconds. If the ball has a mass of 0.2 kilograms, what is the force she exerted on the ball? Hint, what is the change in velocity? Here are our 3 impulse formulas. Pick the correct one based on the information given in this problem. We're trying to find the initial impulse. We were given the 2 velocities and the mass, so I'm going to use this formula right here. Mass is 0.2, final is 25, initial is negative 30. 25 minus negative 30 is 55, times 0.2 gives us an impulse of 11. If I wanted to find my force, and I know that it was applied for 0.5 seconds, I could simply plug in and solve for my force. On your own, solve for the force based on the impulse of 11 and the time of 0.5 seconds. We're going to plug in 11 for the impulse, Time is 0.5. I'm going to divide to solve. So that means I applied 22 newtons of force, or the tennis player did. The law of conservation of momentum states, the total momentum before a collision is equal to the total momentum after a collision. This is the total of momentum of all objects, even if they are two separate objects or multiple separate objects. When objects collide, they can collide two different ways. Elastically, they hit and bounce off each other. Think pool balls. They run into each other and they bounce off. The momentum before of both balls is the same as the momentum after for both. In elastic collisions, the objects stick together or separate. So they either start or end as one object. Two boxcars, one rolls and they latch together, inelastic. A two-stage rocket is also inelastic. It starts as one rocket and then breaks off into two separate parts. To calculate the conservation of momentum, set up each problem as before and after the collision. Determine how many of the objects you have before and how many objects you have after. If you have two objects before and two after, you need to list the mass, velocity, and momentum for each. If you start with two before and two after, you also need to list a total momentum. Some objects, if it's inelastic, may start or end with only one object. Be careful when labeling out your mass, velocity, and momentums. To highlight how this works, we'll look at a Newton's cradle. We look at before and after the collision. We're going to look at the first ball and last ball. We're going to assume that all the momentum from one side transfers directly into the other side, and that's the collision we're really seeing. The first ball is moving in a positive direction, has a positive velocity, has the same mass as the second ball. If I multiply those together, I could find the momentum. The other ball, the ball at the end, is stopped and has the same mass, so it's going to have no momentum. We would be able to find a total momentum with those two together. After the transfer of momentum, the first ball stops, has the same mass, but now it has no momentum after. The last ball is now moving with the same velocity. That velocity got transferred via momentum. Because the second ball, or the last ball, is the same mass, it can also have the same velocity because it has the same momentum before and after. Let's put some numbers into a real-world scenario. We have two train cars, each with a mass of 1,200 kilograms. The moving cart comes in collision at a speed of 20 meters per second while moving to the right. The other car was stopped, but they move off to the right together. Calculate the velocity of the combined cars after the collision. Set up your data as before and after. I have two masses, two velocities, and two momentums beforehand to represent the two cars. Afterwards, they're combined together. This is an inelastic collision. So there's only one mass, one velocity, one momentum. Notice that if I have two objects, I have to have a mass, velocity, momentum for each of them, and then a total momentum altogether. The mass of the first car is 1,200 kilograms. Mass of the second car is still 1,200 kilograms. The first car is moving 20 meters per second to the right. Second car not moving at all. I can find both of these momentums. P equals m times v. So 1,200 times 20 gives me a momentum of 24,000 kilogram meters per second. That's the first car's momentum before the collision. The second car is not moving. Anything times 0 is still 0. So we end up with 0 kilogram meters per second. To find the total momentum before, add up both objects' momentums. 24,000 plus 0 gives me 24,000 kilogram meters per second. This momentum transfers after the collision. So if it's 24,000 kilogram meters per second before collision, it's going to be 24,000 kilogram meters per second after the collision. This is the total momentum of both carts together. I'm trying to find the velocity of the two cars in total. I don't know the velocity and I don't know the mass. However, I started with two 1,200 kilogram carts. They combined together to make one 2,400 kilogram cart. If I want to solve for my total velocity, so the velocity that the two cars move off together, I need to set up P equals mv again, my momentum formula. I know my momentum's 24,000. I know my mass is 2,400. It's just a one-step equation to solve for v. V is being multiplied by 2,400, so I'm going to divide both sides to get 10 meters per second. This is a reasonable answer because the carts end up moving off to the right. They also slow down after the collision. The first cart cuts its velocity in half. On your own, try this problem. Ball 1 with a mass of 0.5 kilograms is moving to the right at 4 meters per second. It collides with ball 2, 1 kilogram, moving to the left at 3 meters per second. One ball is moving to the right, one ball is moving to the left. Think about how that affects the sign of your velocity. After the collision, ball 2 moves to the right at 2 meters per second. What is the velocity of the ball, or ball 1, after the collision? Keep in mind, right for velocity and displacement is positive. Left is negative. I'm going to start by filling in all of my given information. I know the mass of both balls. I know the velocity of both balls before the collision. Notice that ball 2's velocity is -3 because I'm moving to the left. I can find my momentums by multiplying those together. 2 kilogram meters per second. 1 times -3 gives me -3 kilogram meters per second. Remember, the negative just means that I'm moving backwards or in an opposite direction. To find the total momentum, I add up P1 and P2. 2 plus -3 gives me -1. Total momentum for both ball 1 and ball 2 is -1 before. So it needs to be -1 kilogram meters per second after as well. The ball's masses didn't change, so those are going to stay the same. We were also told that ball 2 moves to the right at 2 meters per second. Because the momentum formula has 3 variables, I need at least 2 of them to solve for the third. In this case, I only have enough information to find the momentum, or the individual momentum, of ball 2. 1 times 2 gives me 2, so it's a 2 kilogram meters per second. If I wanted to find ball 1's momentum, I could simply take my total momentum formula, which is P1 plus P2, plug in what I know, and solve for P1. I could also simply take my total and subtract whatever momentum I know. -1 minus 2 gives me -3 kilogram meters per second. Either route works. At this point, if I'm trying to find the velocity of ball 1, I can plug the information I know into my momentum formula. I know that ball 1's momentum is -3. I know that its mass is 0.5. To solve for its velocity, I'm just going to divide both sides by 0.5. -6 meters per second, which seems reasonable because if one ball went off to the right, the other ball is going to go off to the left in a negative direction.